Given that an equals 2Sn plus 3 over 3, where Sn equals sigma I equals 1 to n ai. Find sigma I equals 1 to n 1 over log to the base 3ai times log to the base 3ai plus 2. This video contains the following sections: reading the problem carefully and understanding it, developing a plan to solve it, solving the problem, thinking about it further, and try to apply the approach to other problems. Near the end of the video, there's an additional question which can be solved using a similar approach to that used for solving a specific problem. If you find these helpful, please subscribe to the channel for notification of new videos by pressing the video watermark in the right-hand corner of the video player. An can be written in terms of Sn. Find the sum of the first n elements of another sequence. 1 over log to the base 3an times log to the base 3an plus 2. From the relationship between the nth element of the sequence and the sum of its first n elements, we can work out the general form of the sequence. Substitute the general form of the sequence an in 1 over log to the base 3an times log to the base 3an plus 2. Then work out the sum of the first n elements of the second sequence. Because an equals 2Sn plus 3 over 3. So rearranging the equation, we have 3an equals 2Sn plus 3. 3an plus 1 equals 2Sn plus 1 plus 3. Equation 2 minus equation 1. We have 3an plus 1 minus 3an equals 2 times Sn plus 1 minus Sn, which is equal to 2 an plus 1. We know that 3an plus 1 minus 3an equals 2an plus 1. By rearranging this equation, we have an plus 1 equals 3an. When n equals 1, from equation 1, we have 3a1 equals 2s1 plus 3, which is equal to 2a1 plus 3. So a1 equals 3. Because we know that an plus 1 equals 3an. So an equals 3 an minus 1, which is equal to 3 times 3 an minus 2, which can be written as 3 squared an minus 2, which is equal to, so on, which is equal to 3 to the power of n minus 1, a1, which is equal to 3 to the power of n minus 1 times 3, which is equal to 3 to the power of n. So log to the base 3 ai equals log to the base 3 to the power of n, which is equal to n. Sigma I equals 1 to n, 1 over log to the base 3 ai times log to the base 3 ai plus 2 equals sigma I equals 1 to n, 1 over I times I plus 2, which is equal to sigma I equals 1 to n, a half times 1 over I minus 1 over I plus 2, which can be written as a half times 1 minus a third plus a half minus a quarter plus a third minus 1 over 5 plus so on plus 1 over n minus 1 minus 1 over n plus 1 plus 1 over n minus 1 over n plus 2. A half remains. Now look at the other part of the term. A half times 1 minus a third plus a half minus a quarter plus a third minus a fifth plus so on plus 1 over n minus 1 minus 1 over n plus 1 plus 1 over n minus 1 over n plus 2. 1 and a half remain, minus a third plus a third cancel, and so on. The last term in the bracket, that's minus 1 over n plus 2. And the third last term in the bracket, that's minus 1 over n plus 1, remain. So we can write a half times 1 plus a half minus 1 over n plus 1 minus 1 over n plus 2 Simplifying this, we have 3/4 minus 2n plus 3 over 2 times n plus 1 times n plus 2. Think about the thought process for the previous question further and try to apply the approach to other problems, such as this one. Given that En equals 2 times 1 minus Sn, where Sn equals sigma I equals 1 to n Bi, An equals 1 over En plus 1, Tn equals sigma I equals 1 to n 1 over Ai. Find the maximum positive integer n which satisfies Tn is less than 100. You can write your answers in the comments section if you like. If you have any mathematics questions of interest, you can write these in the comments section if you like. Thank you for watching. Hope you found this video helpful. See you next time.